Okay, so the next portion we're going to go over is we're on 10.4. Okay, and 10.4 is we're going over the probability of multiple disjoints and non-disjoint events. We're going to go over it. Probability of multiple disjoint and non-disjoint events. So, a couple of kind of different vocabulary words here, okay? A disjoint event. Okay, think about this. What does the prefix dis mean? Not. And what do you think if something is joint? Connected, exactly. So basically a disjoint is event is events that have nothing in common. Events that have no common outcomes. We're getting there. Okay, a disjoint event is an event that have no common outcomes. Okay, disjoint events can also be called mutually exclusive. Mutually exclusive. So that means they're things that happen regardless of something else happening. Okay, so they're not related at all. Okay, we will get to ones that are related tomorrow. Okay, so there's a couple different formulas that you will need to know for this. I'm sorry. We'll get to it on our next day. Yeah. Okay, so a couple different formulas you need to know. First one is the probability of A and B happening is equal to, what happens when you have an and? And tells you to multiply. So that is the probability of A multiplied by the probability of B. Okay, so it's kind of like if I told you, what's the probability that it will rain or that we will have rain on Tuesday next week? Is it related? Is having rain related to what day of the week it is? No. So the probability, the probability of it raining on the weekend. Okay, so the weekend is independent of if it's going to rain or not. So those things are not related to each other at all. Okay? So that would be something called A and B. So you would multiply like the probability of it being a weekend day, which is 2 out of 7, multiplied by the probability of rain, which would be given to you. Okay? The other formula you need to know is probability of A or B. And whenever you see the word or is addition. So probability of A plus the probability of B. Okay, so and means multiply, or means to add. So, a couple examples for this. For number 1, okay, if I tell you that a bag contains 6 white, 3 blue, and 7 green marbles. Back to the bag of marbles. Okay, a bag contains 6 white, 3 blue, and 7 green marbles. Okay, I'm going to tell you if 2 marbles are chosen at random, for the first part, I want you to find the probability that they are both white. Okay, find the probability that they are both white. So that means we're going to have to find the probability that the first one is white. And if they're both white, is this an and or an or problem? This is an and problem, multiplied by the probability that the second one is white. So if you have a bag of marbles, we have 6 white, 3 blue, and 7 green. What's the probability that the first one you pull out is white? How many total whites are there? 6 out of how many total? 16. then multiplied by, what's the probability that the next one is white? Let's think about this. Okay, listen. If you picked one of the white ones out, how many would be left? 5 whites out of a total of 15. Okay? So you have to reduce things each time. Okay? This is called without replacement. Okay? This is, I'm not putting it back. I'm not replacing this. Now, you could multiply these together now, or I'm going to tell you what's an easier way to do this is to reduce these first and then multiply. So 6 out of 16 reduces to 3 over 8, multiplied by 5 out of 15 reduces to what? 1 over 3. Now, you can cross cancel if you want to. These 3's will cancel. You multiply through, the probability of both of them being white is 1 in 8. Okay? So I'm going to tell you I would simplify before you actually multiply. So cross cancel, cross reduce before you multiply. Okay? Now, probability of both of them being white was 1 in 8. Now I want you to find the probability that they are both green. Will it be exactly the same? No, because there's different amounts of green and white ones. So again, we're going to find the probability of being green multiplied by the probability of picking another green. So how many greens are there to begin with? 7 greens out of a total of 16 marbles, multiplied by, if I took 1 out, there would be 6 left out of a total of 15. Now, this one's not going to reduce quite as well, but 7 out of 16 multiplied by, what does 6 over 15 reduce to be? 2 out of 5. Divide both by 3. If you multiply those together, what do we get? You could cross reduce, or you can multiply either way. We got 14 out of, what's 16 times 5? 80. And that reduces to be what? 7 over 40. Okay, so you're just multiplying things together. So 7 out of 40 would be your new. Okay, do we have questions so far?
So how do we know if it's and or again?
Well, it says both green. So does that say the word or?
No.
No. So by default, it's an and. If they're both green, that means the first one's green and the second one's green. So you have to use some kind of critical thinking there. Okay? For number 2, example 2, we're going to tell you that a card is drawn at random. A card is drawn at random from an ordinary deck. So ordinary deck means that we're going to have 52 cards. Okay, card is drawn at random from an ordinary deck. First one I want you to find is, what is the probability of getting a jack or a 6 of clubs? What is the probability of picking a jack or a 6 of clubs? So, how many jacks are there total? Probability of jack, or what do we need to do here? Are we multiplying or adding? Adding. Probability of 6 of clubs. So we're adding these together. So what's the probability of getting a jack? How many totals are there? 4 jacks out of a total of 52 cards. Plus, no, there's 52.
What?
You're thinking jokers. Jokers are not in our deck of cards. How many 6 of clubs are there?
4. 1.
Well, let's think about this. How many? The 6 of clubs, there's only one of them out of 52. You are not decreasing this time, okay? Because we're just looking to pick one card. So add these together. Your probability of getting a jack or the 6 of clubs is 5 out of 52. Okay, so key thing here is remembering, is it an and problem or is it an or problem? Okay, let's try, now that one should be fine. Okay, next thing we're going to go to, for number 3.
What was the answer?
Can you put it back?
5 out of 52. We're adding things together. For number 3, if I give you the problem, Sonia is moving, and all of her CDs are mixed up in a box. All of her CDs are mixed up in a box. 12 are rock. 12 CDs are rock. 8 are jazz. 8 are jazz. And 5 are classical. Okay, so given, all of her CDs are there. 12 are rock, 8 are jazz, and 5 are classical. If she reaches in and selects 3, okay, reaches in and selects 3, I want you to find the probability first that all are jazz. So find the probability that all 3 are jazz. So is this going to be an and problem or an or problem? An and problem. So we're going to have to find the probability of being jazz multiplied by the probability of the next one being jazz multiplied by the probability of the next one being jazz. So what's the probability of the first one being jazz? How many jazz are there total? 8 out of a total of how many? 8 out of 12 plus 8 plus 5 is 25. Multiplied by, what's the probability of the next one being jazz?
7.
This is going down, so 7 out of 24 multiplied by what? 6 out of 23. Can any of those be reduced? Not individually, but you can do some reducing here. Okay, this one goes away, that's going to leave you a 4. Can anything else reduce? Can anything else reduce? The 8 and the 4 can reduce. You don't have to reduce these, but it makes life a little bit easier. You will probably want to use a calculator here. So remember, when we're multiplying across the top, just 2 times 7 times 1, so that's 14, divided by 25 times 23, and 25 times 23 gives you 575. Right? That is your answer. That cannot reduce now.
Miss Quinn?
Yes.
Why is it a 1 right there?
Because I cross-reduced. The 8 and the 4 give you 2 and 1. So I did cross-reducing. Okay, now I want you to find the probability that all are rock. Find the probability that all of them are rock. That all 3 she picks are rock. So probability of being rock multiplied by the probability of being rock multiplied by the probability of being rock. So what's the first probability that the first one is rock? 12 total out of 25 multiplied by 11 out of 24, 10 out of 23. Okay, do as much cross-reducing as you can. You don't have to, but it's probably a good idea. What else can reduce?
12 and 24.
The 2 and 10.
That's it.
2 and 10.
So if you do everything multiplied together on the top, I'm going to end up with 11 on the top, multiplied by 5 times 23, 115. So 11 out of 115. Probability that she picks out 3 of them, 11 out of 115, that they would all be rock. Okay, now, the last one I'm going to do is I want to find what's the probability that if you pick 1, okay, probability that if she picks 1, what is the probability that it is her 1 favorite? Doesn't matter. How many favorites will she have?
1.
1 out of a total of how many?
2.
How many total? 25. Okay? Think about that. There's only 1 that's her favorite. So it doesn't matter what kind it is. It's 1 in 25. Okay? Same thing happens as if I say if you pick it first, or what if I picked it third? It's still 1 in the total. Okay? Does not matter which place I'm asking for. It's still 1 in the total. Okay? Questions on how I did that? Next thing we're going to go over are called non-disjoint events. Okay? No. Non-disjoint events. Not very many. Okay? Non-disjoint. So this is kind of a double negative. Okay? Not jointed. Therefore, these are having something in common. Okay? These are considered overlapping. These are overlapping or have an outcome in common. We will do more of these later, but being non-disjoint is something kind of like if I asked you, what's the probability that if I picked one person in my class, they would be a girl or a sophomore? Aren't there some girls that are both girls and sophomores? Right? So that's how things could be related, because the formula for this is going to be the probability of A or B is equal to probability of A plus probability of B minus the probability of A and B. Okay? This is where some things get double counted, and we're going to do more of this in another lecture, but this is something that could be double counted. Okay? So for instance, if I asked probability of picking a girl or a sophomore, you would count out all the girls plus all the sophomores, but then you have to subtract the ones that you double counted, the ones that are both girls and sophomores. Okay? This is probability. If you are thinking about taking stats and probability next year, this is what you're in for. A lot. Okay, so that's your formula for that. Okay, let's see. You also need to know something about complementary events. Complementary events. Okay, complementary events are events that are opposites. Events that are opposites. Okay, so examples of events that are opposites are would be like rain or no rain. Rain or no rain, true or false. So there's only two possibilities. Okay, male or female. Okay, those things are complementary. Okay, night and day, exactly. Win or loss, even, odd, that kind of thing. Heads or tails, exactly. Okay, for number 4. Okay, if I tell you that a card is drawn at random. A card is drawn from an ordinary deck. I want you to find the probability that it is a queen and a heart. Find the probability that it is a queen and a heart. So, you have to find the probability of it being a queen plus the probability of being a heart minus the probability of being both. I'm sorry, yes. Queen or a heart, sorry. I'm sorry. Queen or a heart. So if I pick one heart and it's a queen, I want to know what's the probability that it's a queen or a heart. So you have to figure out what's the probability of being a queen? How many totals are there?
4.
How many queens are there? 4 out of what? 52. Plus, how many hearts are there? 13 out of 52. But you have to subtract how many are both a queen and a heart. How many queen of hearts are there?
4.
1
1.
out of 52. So you counted it with the queens, and then you counted it with the hearts. So you double counted that one card. So that's why you have to subtract it out. So if you add these together, or do the addition and subtraction, 4 plus 13 minus 1 gives you 16 out of 52. And if you reduce that, what do we get?
8 over 26. And then 4.
4 out of 13. Thanks, Steven.
You are
Okay.
right.
What is the probability of being both a queen and a heart? What's the probability of being both a queen and a heart? Two different ways you could do this, okay? The first one is finding the probability of being a queen. And if it says and, we are multiplying by the probability of being a heart. So how many are queens?
4.
4 out of 52 multiplied by how many hearts are there? 13 out of 52. What do you think this is going to reduce to be? If you reduce this, this is 1 out of 13. This is 1/4. I'm just saying if you reduce these before you multiply.
Oh, okay.
So 1 in 52. Or you could just think of how many queens of hearts are there? 1 in 52. So you didn't really have to do all this, but you can if you didn't automatically see that. Okay? Let's try, we'll find the probability of being a queen or a jack. Find the probability of being a queen or a jack. So, probability of being a queen. What does or mean?
Add.
Plus the probability of being a jack. So, what's the probability that you'd pick a queen?
4 out of 52.
4 in 52. What's the probability that you would pick a jack?
4 out of 52.
4 out of 52. Add those together,
8
8 out of 52, and that reduces to 2 in 13.
Are we done?
You'll know.
Not even.
Almost done, guys. Okay, 2 more. I want you to find the probability of being a 5 and a black card.
5 of a black card.
Probability of being a 5 and a black card. And means what? Add or multiply? Multiply. So what's the probability of being a 5?
4 out of 52.
There's 4 out of 52. Multiplied by how many black cards are there?
26.
26 out of 52. Okay, if you cross cancel these, it's going to leave you a 2 and a 1. This breaks down to be a 2. So really, your probability is 2 out of 52, which is equal to what? 1 out of 26. Okay, and then the last one I want you to find is find the probability of not being a club. Find the probability of not being a club. So what's the total probability? What's your total probability? 1 minus the probability of being a club. So you have to do a whole 1 minus what's the probability of being a club? How many clubs are there? 13 out of 52. Clubs are only one suit. So if you change that to be the same denominator, 52 out of 52 minus 13 out of 52 leaves us what? 39 out of 52, which becomes 3/4. Okay, write this down on the side of your paper. Your homework for this is going to be on page 710. You're doing numbers 3 through 27. Okay, page 710 in your book, numbers 3 through 27.